So we will look at displacement and distance. These are similar quantities, one being a vector, that's displacement, and one being a scalar, that being distance. The symbols for these are as such. This is pronounced delta D, as is this. This arrow above the symbol indicates that this quantity is a vector. The lack of an arrow here indicates that this quantity is not. This triangle is pronounced delta, it's a Greek letter, and indicates a change. So D, you can think of as being the position and of an object, and the delta indicates that this describes a change in position. Here being a vector, this being a scalar. Now, when you're looking at distance versus displacement, if you were to take a path following this red line, starting here and ending here, your distance, the distance you have traveled, would just be the length of this line. Your displacement, however, regardless of your path length, whether you took this path or whether you followed the black line or if you took some intermediate path, your displacement would all be the same. Your displacement describes your new position relative to your old position. So in this case, if this was north, east, south, and west, and this was, let's say, 120 meters, your displacement would be 120 meters in whatever direction this was. Let's look from the north. Let's say that was 75 degrees. If that had been 75 degrees, our displacement would be 120 meters north, 75 degrees east. Our distance along this red path might be 135 meters, perhaps by this black path here, perhaps 125 meters. Notice that the distances we travel do not have any direction inherent. In fact, both of these paths travel in multiple directions. Displacement has a direction, and it points from the very beginning to the very end. It also be noted that if you're traveling in a straight line, the magnitudes of your distance, that is how far you've traveled, and your displacement, that is how far you ended up from your beginning point, will be the same, only in a straight line. That being said, in this course we will be working with straight line motion quite a lot. And so, if you were to travel from Owen Sound to Toronto and back, your distance would be close to 400 kilometers, because Owen Sound's about 200 kilometers away from Toronto, so you travel 200 kilometers there and 200 kilometers back. Your displacement, however, since you define the start and end of your trip as being in the same spot, your displacement would be 0. We'll look next at velocity versus speed. Again, these are similar quantities, velocity being a vector quantity and speed being a scalar. Now, in terms of symbols, velocity gets a V with an arrow. Speed is also a V without the vector symbol. Again, speed is a scalar quantity having a magnitude only. It's the rate of change of distance from your reference point. And so when you say you have a speed of 35 kilometers per hour, that means that for every 1 hour of travel, your distance changes away from your starting point, your distance changes by 35 kilometers. It has units of distance over time. Again, the distance you travel per unit time. That time can be measured in hours or in seconds. The distance could be measured in miles or meters or kilometers. In the international system, the metric system, the standard units are meters per second because meters are the standard unit of length and seconds are the standard unit of time. And so your car speedometer, in fact, does measure speed rather than velocity because regardless of the direction you are traveling in, it tells you how fast your distance is changing. It doesn't necessarily tell you how how your displacement is changing, because if you turn a corner, then your displacement changes in a different way than it would have if you had continued going straight. Velocity, however, is a vector quantity indicated by magnitude and a direction. I'll draw the symbols back in here. Velocity is the rate of change of displacement from some reference point. Now, at any given moment, your velocity is equal in magnitude to your speed at that very same instant. However, your average velocity may be much different than your average speed because, again, if you had not traveled in a straight line, then your average speed would be quite different from your average velocity. Why? Because your distance will have been different from your displacement. We'll try and make that clear on the next slide. Again, units of velocity are distance over time, but again, velocity must also have a direction indicated. And so when we're calculating average speed, we take the total distance over some time period divided by the time it took to travel that distance. Whereas in average velocity, we look at the displacement occurring divided by the elapsed time. Now, since displacement is a vector that has a direction, velocity will also have a direction. And so we can look at the equations for both velocity and speed in the average. For over whatever time period you're looking at, average velocity will equal your displacement divided by time. This delta refers to a change in time. What this means is that you're looking at the elapsed time that it took to make this displacement. So this says that velocity equals displacement over time. And this is an average velocity. For speed, average speed will equal the distance you traveled divided by time. And so we can say that average speed, put that into words, equals the distance you travel divided by the time it took you to travel that distance. So if you're traveling from Owen Sound to Toronto and back in 4 hours, recall that your distance would be 400 kilometers and your average speed would equal 400 kilometers divided by the 4 hours it took you to make that, which makes your average speed 100 kilometers per hour. Notice that I kept the units in the calculation, and those units carry over to the final answer. If you ended up with a speed and units of kilometers times hours, you know that something's wrong because you know that speeds come in kilometers per hour. And so the units of your final answer should agree with the quantity that you're actually looking for. Let's look at our average velocity. Average velocity equals your displacement divided by the time it took you to make that displacement. And in this case, because we're looking at a round trip, because we start in the same place as we end, our displacement is 0 kilometers in no direction. And it took 4 hours to do it. Our average velocity would be 0 kilometers per hour. Since our magnitude is 0, there's no direction associated in this case. And I previously said that at any one moment, your velocity will be equal in magnitude to your speed at any one moment. The velocity will have a direction attached to it. So if you're constantly changing direction, say if you're moving around in a circle, your speed may be constant while your velocity is changing, even though your speed and your velocity are at any one moment going to be identical. Your speed, let's say you're going around at 3.0 meters per second. You're traveling at 3.0 meters per second. Your speed is constant. Your velocity as well in magnitude is constant. However, when you're at this point in the circle, your velocity is 3 meters per second to the right. When you're at this portion of the circle, your velocity is 3 meters per second downward. At this part of the circle, your velocity is 3 meters per second to the left. And so, your velocity is changing in direction while staying constant in magnitude. And so while your speed is constant at 3 meters per second, while your velocity is constant in magnitude, that is, say, it's staying at 3.0 meters per second, you're constantly changing direction, and so your velocity is also changing, because velocity has direction inherent in it. And so let's do a question that deals with the concept of displacement versus distance and speed versus velocity. From its starting point, a boat travels east for 80 nautical miles, then turns due south for 192 nautical miles, at which point it stops. Determine the total displacement of the boat from the starting point by either trigonometric or graphical methods. We'll use a combination of both. If the average speed was 80 knots, or 80 nautical miles per hour, what was the average velocity in knots? Let's also identify the given pieces of information as scalars and vectors, also the components of our answer that are vectors and scalars. So let's take a look at that. From some starting point, this boat